Hello, and welcome to Mint and Burn, the academic analysis of blockchain and other technologies in the decentralized digital economy. I'm your host, Kelsey Nabin, and we are tuning in remotely from the RMIT University Blockchain Innovation Hub to bring you interesting guests, publications, and experts to test frontier ideas. This is episode number 4 of Mint and Burn, and today we'll be talking to Mark Miller, Chief Scientist, and Bill Tuller, Economist at Agoric, on Agoric Markets, along with resident experts from the RMIT Blockchain Hub, Professor Jason Potts and Professor Sinclair Davidson. Welcome. So let's start by being very kind to anyone listening to this and explaining what are Agoric Markets.
So the original definition back in the Agoric papers that Eric Drexler and I wrote in 1988 is a software system using market mechanisms based on a foundation that provides for the encapsulation and communication of information, access, and resources among objects. So that sentence, obviously, I'm trying to pack a lot in there. So let's unpack it some. The encapsulation and communication is a sort of primitive rights theory that is a way to look at properties that are pretty much universal to modern computation, to modern ways of writing programs, which is that you have these units of organization, objects, modules, applets, etc. You have these units of organization for which I'll generally just be using the term object to refer to all of them. And they have some stuff inside. They have some data that they manipulate that is inside the object, and then they communicate to other objects by making requests, by calling functions, by calling methods, by sending messages. There's various forms, but all of the concrete means by which they make requests of each other, but we can just consider all of them to be requests. And those requests can carry information and can carry access to other objects. So for me, the big aha moment that started me on all of this was back in 1983. I was very excited about object-oriented programming, which was where this notion of encapsulation and communication, sort of this notion of organizing computation around this sort of property rights like notion of ownership and transfer. Uh, that was where it started for me. Is I was interested in that, and I was interested in Hayekian economics, and I was explaining to a friend of mine, Eric Drexler, how excited I was about object-oriented programming, and he said to me, "Oh, that's like Hayek's explanation of what's good about property rights, that society has a massive plan coordination problem, that you have zillions of different agents making plans for the use of various resources, where these plans are formulated in ignorance of each other, and the plans, if they simply happen to conflict in using common resources, can create a nightmarish plan coordination problem. So by dividing up the resources into these separate plots, uh, and such that each owning person or corporation, each owning entity, can make plans exclusively in terms of what they own, knowing that they're not subject to arbitrary conflict of interference from the plans that others have made. Now you've done a lot to reduce the plan coordination problem, and as um, the Austrians here will appreciate, the center of Hayekian economics is the plan coordination problem. How is it that separate plans formulated in ignorance of each other tend to mesh well? And that aha moment where Eric said that I realized that all of that is also the central problem of software engineering. And the big advance of object oriented programming in the early 80s was the rediscovery of essentially that same organizational principle with regard to giving small portions of code exclusive access to particular pieces of data, and then allowing the code to communicate requests and access as they make requests of each other. Um, so that led to the Agoric papers in '88, in which we are trying to paint a unified notion where during the intervening years, we translated back and forth several times between our understanding of software engineering and our understanding of economics. And we're trying to help software engineers better understand how to view software economics, software engineering from this Hayekian economic perspective, and how to import into software engineering ideas from economics to help software engineering. And in particular, these were the early days of distributed systems. I was at Xerox PARC. Ethernet had been invented not terribly long before. Distributed systems were just getting started. Uh, and Eric and I realized that the central planning approach to resource allocation in computational systems was not going to scale. It was going to break down. So we wanted to import price mechanisms as well into computation based on this Hayekian bridge between computation and economics to import price mechanisms so that computation resources were allocated with dynamic pricing, processor scheduling, for example, being auctioning off the next time slice, the next slice of what the computer's processor does next, and that this price information would guide each of the participating units of computation to make decisions as if guided by an invisible hand that would serve the utility of the system as a whole. And at this point in the story, Bill comes in.
Thanks, Mark. That's a very elegant kind of summary of the kind of aims and objectives, but also the link between the computer engineering and the economics. Bill, obviously a lot has happened since the 80s. Tell us where you're at in terms of the project.
Yeah, well, as Mark said, I first came into this in 1989, but coming more, Mark came at it from the computation side, where my background was economics, and uh, we back then saw that this was really the future of where things were going, and decided that this was what we wanted to spend our lives doing. And since then, we've been in various ways, both Mark and I, trying to make this happen. And back in the early 90s, we started a company called Agorix that tried to realize this. And this was started even before the World Wide Web days. And, obviously we were a little bit too soon. But now with blockchains coming, we've realized that, we have another chance to realize a lot of the dreams that we saw back then. So we formed a company a couple of years ago called Agoric that is, building a blockchain and trying to realize the vision that we saw back in the 80s.
Phenomenal. And then Sinclair and Jason, you guys have been doing some work with the Agoric team. Tell us a little bit more about what you've been working on.
Well, it was very interesting because I think it was 2017. It might have been maybe 20. I think it was 2017. Jason and I were in at Berkeley at a conference, and we were presenting the ideas of Oliver Williamson in the blockchain space. And by I think pure coincidence, Bill was there and liked our talk and actually came and spoke to us in one of the tea breaks. So we had a long, long chat to Bill, and it turns out Bill is actually a graduate of George Mason University, which is one of our favorite universities, because the economics program there is very different and unique compared to many other economics programs. And the next year, I think 2018, we met up again in New York at Consensus, where Bill introduced us to Mark. And I think we met more or less at a tea time. It was a very quick hello. But the next morning in the breakfast hall, Mark was looking for a place to sit and have his breakfast, and I saw him, and there was a seat next to us. So waved him over, and I said, "Mark, come and sit here." And he came and sat down, and we then discovered our interest in Hayek, and what Mark is calling sort of the agorics project, we would call the socialist calculation problem. Because how does a centralized economy organize and plan itself? And it can't. And Mark had realized that same problem from a computer science perspective, because he'd also, because I said to Mark, your economics is awesome. Where do you get it from? And he said, oh, Don Lavoie was and the late Don Lavoie is somebody we know well. We've read all his works and what have you, and we ended up just spending hours and hours and hours talking about Hayek and the problems, and it's more or less just taken off from there.
Yeah, what's remarkable about this is just the consilience of having this very general abstract problem of coordinating distributed, a group of people or a group of things coming together to solve a complex coordination problem. And so just seeing um, the the types of solutions in completely different fields. And so there's this notion that markets can coordinate through the price mechanism, economizing on information to make distributed plans mesh together is just the sort of miracle of how economies, how decentralized market systems work. And I think Sinclair and myself were just astounded at first, just to realize that you've got exactly the same problem deep in computer science in a field, a million miles away from there, but has the same sort of architectural complexity of bunches of different sort of bits of code needing to coordinate access control to merge and mesh their plans. And I think this is the what we just found absolutely fascinating about this idea of agoric systems, um, from very, very different perspectives coming together and having the same sort of class of solution. It's been fascinating. And this connection to Hayek, who, this was 60 years ago, 70 years ago, sort of more or less laid out a lot of these core insights, well before we had a digital world to put all that back together again. So, incredible sort of intellectual consilience.
Amazing. So where are you guys at in terms of this idea of computational markets? Like how has it been developing, both in terms of what you've built or what you've tested or launched, and kind of what are the ways that you've watched people engaging with it?
We are building a smart contracting system on top of a distributed object capability system, on top of a blockchain infrastructure. So there's several levels here, but the underlying core theory is very much pervades all of the levels, which is again this encapsulation and communication as a way to coordinate. Uh, the so at Agoric, we're uh, building on our decades of research on how to do language-based, programming language-based support for smart contracting so that the contracts can be written understandably and reliably so that uh, programmers who are not specialists can succeed at writing contracts and can uh, read those contracts and have a good chance at understanding that the contracts mean what they think they mean. What we've seen in the rest of the blockchain world is quite the opposite, is that contracts are incredibly hard to get right, that experts spend tremendous amounts of effort trying to get a contract right. They'll then go and have it audited by other firms that inspect it and try to uh, give it a clean or dirty bill of health. And then we've seen these things get deployed, and due to a bug, hundreds of millions of dollars disappear overnight with no recourse. Now, this will happen in any software system. Bugs happen. We're not going to make bugs not happen. But the key thing was the nature of the bugs. In our research through especially the early 2000s, around my research language, the E language, we had an open source community writing smart contracts in E. E itself was a language, it was a general purpose secure distributed language, but in which the driving use case that the research was around that drove the language design was smart contracts. And we figured out how to use it well to write smart contracts. We figured out good patterns. And as we saw a lot of these bugs happening in the blockchain world, so many of us were saying, if they had only been writing the contracts the way we had come to understand how to write them, they wouldn't have had these bugs. So we realized there was an opportunity here. And we're now bringing our understanding of how to support the writing of contracts, both at the language level and at the patterns of organization and at the abstractions, and together with a whole bunch of new innovations around the writing of contracts that improve quite a lot over what we had understood in previous decades. So we're doing that. And I've been focused on building up to the smart contracting layer, assuming that we have an underlying blockchain system that works as a reliable computer. Um, uh, Bill and Jason and Sinclair and the other RMIT people, the RMIT people have been collaborating with Agoric on closing the loop, on bringing the set of market institutions that we are now creating by writing smart contracts on our infrastructure to use those to create the incentive underpinnings for the blockchain, so that our blockchain is itself built on a system of self-stabilizing incentives to create a robust blockchain. And I'll let everybody else talk more about that.
Yeah, that would be great. Feel free to jump in.
So, an important part of what Mark has been talking about is actually defining property rights. When you trade goods and services, what you're actually trading is a vector of property rights, and you can describe the good that's been traded in those attributes of the good. So the agoric system actually allows you to specify what those goods and what those vectors are, and then trade them and price them. Which I think is actually understanding what is going on in a blockchain from a deeply profound economic level, which is something that we certainly don't see that much of in this particular space. So, what Mark and Bill and the others have been doing has been very much focused on getting the underpinnings, the economics, the property right aspects of this correct. And that's what makes this particular project very exciting. But at the same time, when you are building economic infrastructure, which is really what a blockchain is, when you're building this economic infrastructure, you have to get the economic institutions correct. Now, nowadays, people think of economic institutions as, oh, we've got a reserve bank that does money, we've got regulators that do all sorts of other things. But in a blockchain space, you're actually more or less building an economy, and you've got to get that economy fully integrated with the outside world, with other opportunities, in order to get a viable blockchain going. So that's what we've been thinking about, working with, making sure that there are arbitrage opportunities, that there's no artificial pricing, there are no artificial choke points in the system, nothing that would actually make it not work well. And this has actually been very interesting and challenging from an economics perspective, because you've got to think it's the property rights that are important, it's the pricing that's important, it's the opportunities to trade that are important. And that's what you have to build in when you are building a viable blockchain solution to trade opportunities. And that's what we've been doing over the last few years. It's been very, very exciting work.
Incredible. And can you talk about what the Hayekian or the Austrian economics approach to property rights is, to kind of close that loop for us?
Well, how I would think of that is not just Hayekian, but also to a large extent the UCLA approach of people like Armin Elkian and Harold Demsetz, where they also had defined property rights as not relationships between people and goods, but relationships between people and people. What are you trading? You are trading this vector of opportunity, this vector of attributes from one to another. And so it is a case of allowing prices to work in a system, in giving people opportunities to meet and trade, as opposed to specify how that trade is actually going to work out. So the Hayekian approach of not planning an economy, but rather giving market space for people to operate, and then to define what those objects are that people are trading.
Yeah, the other interesting aspect of the Hayekian or the Austrian approach to economics is how it conceives it as a complex, evolving, emergent system. And that notion, I mean, and what this is particularly interesting from the perspective of knowledge. So the Austrian conception is that an economy is made of institutional specifications, of institutions that establish property rights, that create rules, and that those rules relate to particular things, resources, and so on. And that what an economy is doing effectively is an emergent rule system that is made of sort of base layer rules that establish property rights. It's made of another layer of rules that establish contracting and exchange and agreements and so on. You've got this stack of this rule system stack. And what is going on then is that economic activity is the is the coordination of people coming together, using those rules to coordinate their activity with other players in the system. But what an economy then is this emergent, evolving rule system that, from a fundamental perspective, is therefore it's not predictable in a sense. You can't plan it, and it's able to sort of create emergent structures, and these emergent structures are the patterns of economic organization. So what the Austrian perspective ends up doing is just being very skeptical of the ability to plan an economy, or skeptical of the ability of high-level policy to come down over the top of it. What that means then is that what a good economy looks like, what an effective economic institution mechanism looks like, is a well-designed emergent stack of rules that is able then to enable people to come together and do all of the things that they need to do. And this sort of goes back to this notion before about that's the same challenge that you have in a very complex software system, is that it'll start to have these, it's sort of an emergent stack of rules and capabilities that then creates capabilities for things to happen.
Yeah. So a important shift in perspective that happened since we wrote the original papers is, the original papers, we saw this as an analogy between the human world of economics and the internal world of software systems, that both of them can be considered networks of entities making requests of other entities, where the knowledge of the different entities is composed together to bring about greater utilization of knowledge than any one of the entities could have done. But these were just two analogous systems back in the 80s. Today, we look out at the world, and the world is already one in which people make requests of people, people make requests of objects and software, objects make requests of objects within the internals of software engineering, objects make requests of people. Think about workflow systems or an Uber driver. Um, so we've got a complex emergent economy that is where the networks involve both human to human request making and object to object request making and all of the other combinations as well. And when you take this uniform view of it and you can introduce smart contracts in a smooth manner where the players might be programs operating on behalf of people at a variety of levels of abstraction, but the different roles can be occupied by people or software in ways that can change hands over time and still have the emergent structure of the system be this emergent cooperative request making, producing great wealth.
Yeah, I'm really glad you brought that up, actually, Mark. There's another great paper, one of the agoric ones from the 80s, on this idea of evolutionary computation. And I'm curious, like, how far does this idea go? And it's nice that you draw it into the real world around objects and people making requests. But does AI and automation play into this? Like can you sort of science fiction it for us a bit as well, in terms of not a defined end state because it's evolutionary, but like how this could evolve?
There's a lot of discussion these days in certain circles about AI dangers and about the dangers of superintelligence. And a lot of this discussion around that assumes that the whole issue of human beings um, dealing with the dangers of superintelligence, that these are new things, that superintelligence is something that human beings have not encountered before. In fact, large human organizations are superintelligences. And when you take a look at a lot of this literature, you see that they have many of the same characteristics as the hypothetical new superintelligences we're supposed to be worried about. So our perspective is that the history of political science and institutional economics and all this is already essentially a history of how do we manage these superintelligences so that what they're doing is aligned with human needs. All of the issues in political science of separation of powers, et cetera, all of these things are ways to manage superintelligences by having them be part of a larger network where they're balanced against each other, and the emergent property of the system is still, as much as possible, peaceful and cooperative and not centralizing. So we see the the civilization as a whole is already a superintelligence that's emergent from the intelligence of people and software. And as software gets more intelligent, more of that intelligence will come from AI, but it will still be an organic overall emergence. And to the degree to which we can increase cooperative interactions, we're accelerating that. And a smart contracting fabric that creates risk-free cooperation that can be quite expressive will certainly help accelerate that.
Yeah, interesting. So how do you build security into this system as well? Like you mentioned before, that you're using a coding language which is kind of human readable, and part of that is around security. But then you also mentioned that the Agoric smart contracting layer is built on a secure blockchain. I guess what about the other layers here, or how do you try to ensure security in the social and the technical, I guess, of such a complex economic system?
The way I think of security here, I mean, there's lots of different ways you can think about, but I sort of think David Hume put it best when he talks about the stability of possession, its transference by consent, and the performance of promises. And so we're trying to build a system that enforces property rights and the credible commitments that people need in order to create cooperative systems. And in order to build this as an emergent property of the system, you have to build it in these layers of abstraction. And traditionally, we sort of focused, especially Mark, on this smart contract programming layer. But for that to be secure, it needs to run on a secure computational platform. And that's what blockchains give us by allowing us to have credible computers that we can rely on, because it's not controlled by one entity, but by the consensus of the group running the blockchain. That gives us a much higher level of security of the underlying system. But that alone is not enough. You also need a programming language that allows the programs running on this blockchain to be able to interact securely. And that's where our object capability architecture that's built into the programming language plays a role. And then on top of that, you need to build the more institutions, that the property rights and exchange mechanisms, what we call our Zoe platform and our ERTP, or electronic rights transfer protocol, that actually allows for the secure transfer of possession by consent. And it's by building up these layers, and it's really taken not just us but this broader community some 30 years to really figure out how to build these layers, that we're finally getting to the point where we can have this level of secure cooperation occurring online.
One of the themes that comes up is there's no such thing as perfect safety, but what you can do is partition risk, is have, if there's some large knot of risk, if you can partition it into separate. Let me give an example. So at Agoric, we have an invention that we're calling Zoe that provides a new safety property we call offer safety. Offer safety means that instead of the participants in the contract handing the rights at stake to the contract itself, instead they put the rights into escrow with Zoe and make offers. The problem with giving the rights to the contract itself, which is what everyone was doing, including us until recently, is that if there's a bug in the contract, the rights at stake in the contract are at risk, and that's a lot of risk. And a bug in the contract can thereby cause the entirety of those rights to get lost. Offer safety says at a low level, we can organize a basic quid pro quo mechanism using a fixed amount of code, which is Zoe itself. Zoe holds on to the rights to be reallocated according to the decisions of the contract, but in putting the rights in, each of the players makes an offer, says, in exchange for putting this in, I want these rights back. Zoe guarantees that the only reallocations the contract can do are ones that either refund the rights that were put in or give back what the offerer had asked for in return. When I explained this to the RMIT guys, Jason said, "Oh, that's an Edgeworth box." I said, "What?" Um, uh, so it turned out that we had come across we had sort of independently reinvented a pattern that was used for analysis in economics. But the key thing here is that a bug in the contract can still do damage, but it's the residual damage after offer safety is taken care of, after the quid pro quo of the basic contract is guaranteed. And that residual damage is often tremendously smaller than the risk you had started with.
Oh, that's fantastic to start to see the interactions between disciplines as well. Sinclair, you're going to jump in?
Well, I was going to say the Zoe is an astounding idea. When Mark explained it, we were sitting in San Francisco, and Mark was at the whiteboard, and he drew it out. Jason and my jaws dropped because one, yes, it is an Edgeworth box, but it's actually a practical application of an idea in economics that. Whenever you would teach it, you always say, "Look, this is just an abstraction, an idea. It never really happens like this, but here it actually was being coded up that people will be trading on it." But the other thing that I can't really overemphasize how exciting it is the offer safety. Um, Whenever I look at blockchain products now and apps and what have you, very often the first thing that springs to my mind is this needs offer safety, and Mark and the Agorix team have come up with this idea that's going to make trading on blockchain so much easier and safer than it has been before. It's an astonishing breakthrough and incredibly exciting. So it's just been wonderful watching it sort of just emerge.
Yeah, it's also interesting just to see. I mean, again, just to go back to this really basic point that what you've got here is an advance in computer science and contract engineering that's providing, reducing, adding security and providing offer safety and so on. And that's a good thing. You think, well, of course we want that. That's like privacy is a good thing, and security and safety. These are all good things. But the point that Mark made before, I think, is incredibly interesting here. Is that from a technical perspective, safety and security and those sort of features are good. But what they do, I mean, from an individual perspective, but what they do is they lower the cost of cooperation, or they lower the risk that comes from cooperation, which then puts this very much into an economics context of exchange and an economy is basically an infrastructure for cooperation, and all of the institutions and rules and laws and so on that constitute the order of an economy are technologies that lower the cost of cooperation. And when you have that, that's where wealth and growth and human flourishing comes from. And to sort of see this connection between the computer science, engineering, development of increased security in office safety and contracting, um, mapping directly to this is how you build an economy, and that connection between you know is completely seamless in this infrastructure. And this is why this notion that what agoric is you computable infrastructure for an economy. It is actually, it's not a metaphor. It's
It's actually happening on the ground. We saw it. We thought, wow, this is like really abstract economic ideas just suddenly coming to life before your eyes and actually being coded up.
It's yeah, it's pretty phenomenal, I guess. Even from when you guys started in the '80s with some of these ideas, you said before the web, and I think, I mean, for a lot of kind of concepts around distributed coordination, they kind of haven't gone that way, in terms of central planning versus decentralized planning. I'm curious about your perspective towards the role of governance in this economy. Anyone can jump in.
I think that throughout history, people have had all sorts of ideas about governance. There's been a tremendous number of fantasies people have had that if only we could organize society this way, things would be so much better. One of and a lot of those plans have gone wrong, and some of them in going wrong have ended up causing millions of deaths. Um, uh, the um, one of the things that is exciting in this domain is that you have an inherently nonviolent system within the digital realm. You can have people take their excitement about all sorts of ways to organize things, different forms of democracy, different ways to make decisions, and try them out. And this exploration, many of these will fail. In biology, most mutations are fatal. Likewise, most ideas will turn out to have a flaw in them, but some will succeed brilliantly. And a small number, a bit of progress on discovery of better governance institutions is a tremendously important form of progress. Um, so there's various very interesting experimental ideas like Robin Hanson's futarchy, all sorts of things that can be tried. In the blockchain world right now, there's all sorts of experiments with different forms of governance and voting schemes. So obviously, we're inclined in particular engineering directions in the governance systems we're